Okay, is my presentation visible to all? Students?
Yes, sir.
Okay. So we have studied mesh analysis. So as I said, let us see the difference in nodal and mesh analysis. Mesh analysis. First point is, in mesh analysis, we apply Kirchhoff's voltage law. Okay. Mesh analysis is also referred as loop analysis. So the application of Kirchhoff's voltage law decides the analysis of the given circuit. In node analysis, or rather nodal analysis, the application is of KCL, Kirchhoff's current law. Okay, so Kirchhoff's laws are basically used to verify or to do the analysis either mesh or nodal. Another name given to mesh is loop analysis. So it means in KVL or in mesh analysis, we consider loop and loop currents. We consider loop and loop currents with orientation. With orientation. Orientation means direction. We consider a specific direction, and with respect to that specific direction, we generally find out the equations, right? Okay, just a second. Someone wants to be in. So this is what mesh analysis. In case of loop analysis, in case of nodal analysis, the loop, instead of loop here in nodal, we consider nodes and and node voltages Now these node voltages are decided again based on the orientation of branch currents. Orientation of branch currents. So this is very, very important. Nodes and node voltages. Like if I just consider a particular circuit, say there are 3 resistances connected in a network with 2 voltage sources. If I say this is, say, V1, V2 with the resistances R1, R2 and R3. While application of Kirchhoff's voltage law, you consider loop. So it means you identify the loops which are present as loop number 1 and loop number 2. We are not talking about the super loop, and even we are not going to talk about the super node presently. After understanding that analysis, we'll go with the super node. Okay, so we have first loop and second loop. With respect to V1, if we say that V1 is greater than V2, we follow that polarity of the first voltage source. We consider the first voltage source ka polarity and we give orientation to this. So we get, say, I1 in clockwise orientation with respect to V1, and even I2 with, and the reference for the consideration of I2 orientation is all again V1. Okay, so we consider loop and loop currents. Now what are loop currents? I1 and I2 be the loop currents. I1 and I2 be the loop currents. So with respect to I1 and I2, then we form the equations. So we get loop equations. We get loop equations. Okay. Okay. Now, can you tell me the formula to find out the number of loops? If anyone remembers it, can tell me number of loops, number of mesh.
Equal to E minus
E
N plus
minus
1.
N plus 1.
Okay. E minus N plus 1. Fine. What M indicates?
Mesh.
Mesh.
Number
E indicates
elements.
elements. N indicate
Number of nodes.
number of nodes. Very good. So we have mesh, elements, and number of nodes through which we can find out the number of loops present in the circuit. Like in this case, if I say there are 3 elements present, or rather there are 5 elements present: element 1, 2, 3, 4, 5. So just a revision. So the number of elements are 5. Number of nodes are, this is number node 1, number 2, node 2. This has number node 3. But one more node which is present here, and we can call it as a common node as node 4. So there are 4 nodes. So 5 minus 4, that is 5 minus 4 equal to 1, right? Plus 1, and therefore it is equal to 2. So this way we can find out the number of node or number of mesh present in the circuit. Similar way, for the calculation of number of nodes, for the calculation of number of mesh we have seen. Now for the calculation of number of nodes, the equation is number of nodes is equal to, or rather number of node equations is equal to n minus 1. Like if the number of nodes present in this particular case, like in this particular case, how many number of nodes are present? There are number of there are number of nodes equal to 4, right? So 4 minus 1. So it means the number of equations to this particular case is 3. We are talking about number of node equations. We are talking about number of node equations. Okay. So number of node equations as n minus 1 equal to 3. N minus 1 equal to 3. Okay. So here in this particular case, the number of loop is very, very important rather than knowing the number of node or number of node equations. Okay. Now, as we have seen, we have to consider the Kirchhoff's current law. Like Kirchhoff's voltage law says, summation of V, right? Summation of V is equal to summation of IR. Summation of voltage is equal to summation of IR, right? So summation of V means the supply voltage. Summation of V means supply voltage, and I into R be the voltage drop. Be the voltage drop. Supply voltage and voltage drop. Now KCL means summation of current is equal to 0. Summation of current is equal to 0. Now this summation of current is equal to 0 at a node. At a node, we say summation of current is equal to 0. Other way of writing this Kirchhoff's current law is, if you remember, summation of IC is equal to summation of OC. Can anyone tell me what is summation of IC and summation of OC? Can anyone just tell me what is summation of IC and summation of OC? Summation of IC is equal to summation of OC. So what is IC and OC stands for? Anyone? Right now 30 participant students are present in the class. So I can see that there is a post Diwali effect. Even I am also on leave, but still taking your class. So I cannot deny my duties. Yes, Samay is correctly written. It is incoming and outgoing currents. Correct, Samay. It is summation of incoming current is equal to summation of outgoing current. So I can say that summation of incoming current is equal to summation of outgoing current. For an example, if I just say there is a one node connecting 3 branches. This is your node. And this particular node is connecting 3 branches. Okay. Here the branch current is say I1, another I2, and third is I3. So can anyone tell me the equation to this particular simple circuit? Anyone?
Sir, incoming current is 2 and outgoing current is 1.
Very good. There are 2 incoming currents, but one outgoing current. So summation of incoming current is equal to outgoing current, right? So what I can write is, just a second. So as there are 2 incoming currents, so you can write it as summation. Summation, it means you have to add. So it is I1 plus I2. But there is only one outgoing current, so it is equal to I3. Now there is one more way of writing that. Summation of I equal to 0 at a node. Now what I can take is, I can transfer this I3 on left hand side so that I can write it as I1 plus I2 minus I3 is equal to 0. Now it means what we are doing, whatever the currents flowing towards the node, right, from this particular equation, I just repeat that equation on next slide. So what we wrote as I1 plus I2, but the third current is with written with negative sign, and we are following the equation as summation of current I equal to 0, right? So it means what we did is, the current which is towards the node, the current which is towards the node is represented with positive sign, and the current which is moving away from the node, it is written with the negative sign. It is written with the negative sign. Now you can ask me whether a vice versa is possible with this. Yes, vice versa is possible. If you are saying towards the node is negative, then you have to take away from the node as positive. It means like when we say I1 plus I2 equal to I3. Either you can transfer that I3 on the left hand side, or I1 and I2 both you can transfer it on the right hand side. In that case, what you can write is I3 minus I1 minus I2 is equal to 0. I1 and I2 both is written with the negative sign, but I3 is written with positive sign. So you just consider any one sign convention. Many students write it as sign convection, sign conversion, falana. But the proper way is, the proper word to that as sign convention. Sign convention. We write the equation by considering its direction. That is sign convention. So I just follow this particular sign convention. Whenever the current is towards the node, it is positive, and away from the node is negative. Now, I just consider one more example. The example which we considered just now for sorry, for mesh analysis. Now what you have? Again, you have 3 resistances with 2 voltage sources. With 2 voltage sources. Okay. Now I just say this is 100 volt, 10 ohms, 75 volts, say maybe 15 ohms, okay, and this one is say 30 ohms. So likewise, we have a circuit which consists of 2 voltage sources, 3 resistances connected in the network, and we have to form and we have to solve the circuit. Let us say we have to find out the current passing through 30 ohms branch. So now I have started with the example to understand the method called nodal analysis. Okay, so before getting the solution to this particular network, I just want to do the revision of the points which we discussed. Nodal analysis is the topic for today's class. I already said, like mesh analysis, where we use KVL to find the equation, to form the equation. In nodal, we are going to use KCL, Kirchhoff's current law. It says summation of current is equal to 0 at a node, means summation of currents reaching to the node or reaching at a node is equal to 0. In other words, or summation of incoming current is equal to summation of outgoing currents. In case of mesh analysis, we consider loop and loop currents. In case of nodal analysis, we use nodes. We consider nodes and node voltages. But that again completely depends on the orientation of the branch currents. Here we have a difference in loop current and branch current. Like in this particular case, if we represent current on the branch or current passing through the resistance, then that current is called as a branch current. This particular current is referred as a loop current. If I say we have I1, we have say I2, we have say I3, then these 3 currents are branch currents. These 3 currents are called branch current. That is what the difference in loop current and branch current. So loop current means the current which is considered in the loop, and the branch current means the current which is passing through or which follows the path of the resistance or the elements which are present in the circuit. Okay, so that current is called as branch current. The current which follows the path of branch, the current which follows the path of loop. So that is what the difference is. So loop current, branch current. Hopefully you all are clear with this concept of loop current and branch current. Yes, this is just a Viva based point topic which may be asked to the student. Otherwise, this concept is not so important, but you can easily remember. So In nodal analysis, KCL is applicable. Node and node voltages are important, but that completely depends on the orientation of a branch current. The equation is incoming current is equal to outgoing current. Number of node equations can be found out by using n-1 equal to 3. If I just consider this particular example, I can write it as I1 plus I2 equal to I3. That is summation of incoming current is equal to summation of outgoing current. Rearrangement of the equation, the terms can give me I1 plus I2 minus I3. That gives me the sign convention understanding. So that adds one more topic into it. That is, if the current is towards the node, I have to represent that current with a positive sign, like I1 and I2 in the branch in the circuit is flowing towards the node, and therefore it is written with a positive sign. Where the current is away from the node, if the current is flowing away from the node, then that must be represented with the negative sign. Okay, so that's all with this introduction to the nodal analysis and with the equation. Now let us consider a simple one example where there are 3 resistances connected with the 2 voltage source, right? Now what you have to do to apply this Kirchhoff's current law, KCL, and at the same time when you have to write the expression or the matrix, expression or the formation of matrix, that is to be done by inspection, like in mesh analysis we did. What we did in mesh analysis, we formed the expression, we formed the matrices by inspection. And similar methodology you have to do for the formation of expression or the matrix for the given circuit by using nodal analysis. Okay, so now if I just apply mesh analysis to this particular circuit, I can easily write by considering the loop equations. I just redraw that circuit here. And give the revision to the mesh equation formations or the mesh matrix formation. So now I am going to directly write down this instead of wasting much time onto it. It is 10, 15, 30. 10, 15, 30. Okay, as we know, there are 2 loops present in the given DC circuit. With the loop current orientation is say clockwise, I1 and I2 both are flowing clockwise. The matrix can easily be formed. That reminds me 2 by 2 matrix with the currents which are unknown as I1, I2. We have to find out the current passing through this 30 ohm branch. So it means the 30 ohms is current means the branch current with the voltages 100 volt and minus 75 volts. Why we are writing negative sign here? Because the current which we considered in that I2 ka orientation is positive to negative for 75 volts. And as that current is positive to negative, the particular voltage must be written with the negative sign. That is what the basic concept says. Now we have to write the matrices, 2 by 2 matrix that is to be formed for the given resistances. This particular gives me first row, first column as 10 plus 30, that is equal to 40. This gives me minus 30. This gives me minus 30. And this gives me 30 plus 15, that is 45. So this is what I into R is equal to V. And that is summation of IR is equal to summation of V. Is it clear to all?
Yes, sir.
Okay. So now, how much time you have, like you need to write the, just a second. How much time you need to write the expression for this? You just need very less time. right? So this is summation of IR is equal to summation of P. Now, similar way, you can write down the nodal equation. Now, how to write the nodal equation? If I just generalize this resistances, so what you wrote is, this is say R1, this is say R2, this is R3. Then what you wrote is, you wrote R1 plus R3. You wrote this as minus R3. You wrote this as minus R3. You wrote this as R2 plus R3. ठीक है, आपने ये किया था. अब आपको नोडल में क्या करना है? See, this nodal will give you the same answer. First, convert this given circuit convert this given circuit into current source, because then only we can write down the summation of incoming current is equal to summation of outgoing currents. No, we have to write down summation of incoming current is equal to summation of outgoing current. So to write this concept, to write this expression, we have to convert all the voltage sources, whatever may be the voltage source, if it is present in the circuit, you have to convert it into a current source. So we'll see more and more examples related to that, so you don't worry. Presently, you just try to understand the concept, the process. So convert this given circuit into a current source. Now, how many voltage sources which are present in the circuit? Just see. Voltage source means a voltage source with the resistance connected in series. So this is your first voltage source, and this is second voltage source. So these two voltage sources are present in the network. This is just a resistance which is connected intermediate in between two loops. So it's an intermediate resistance. So convert these two voltage sources into a current source. What is current source? Current source means a current source with parallel resistance. Now, when we have a voltage of 100 volt and 10 ohm as voltage source, the value of that current is equal to voltage upon resistance, right? Now, what is voltage? Voltage is 100 volt. What is resistance? It is equal to 10, and its answer is 10 ampere. Okay, so the value of that current is 10 ampere. The value of that current is 10 ampere. But now you have to decide the orientation of the current, and that can be decided based on the positive sign which is present in the source. So when the positive polarity is upward, the direction of the current source is to be upward. So that 10 ampere current is moving upward with the resistance for the current source is 10 ohms as it is written. That's all with the conversion of first voltage source into first current source. Okay. Similar way, you can convert another second voltage source into a current source, just again by a current source with its parallel resistance. Now, the value of that second current source can be found out by using second current conversion. So conversion of a given circuit voltage source into a current source. So I2 is equal to V2 upon R2. I think all of you can see this. I2 is equal to V2 upon R2. Now what is V2? V2 is 75. R2 is 15. So what you can write it as? So what you can write it as? 75 upon 15. 75 upon 15 is, how much is the value? 15 4s are 60. 15 5s are 75. So it means it is 5 ampere. So this is what 5 ampere. So it means the value of that second current source is 5 ampere. Right? Now we have to again decide the direction of the current source. Can you tell me that direction? So the direction of that current source based on the positive polarity in that voltage source, which is to be upward. What should be the value of this internal resistance of the current source? It should be same as the internal resistance of the voltage source, that is 15 ohms. Now what we have left in the circuit, what is left? The only left part in this is a resistance is of 30 ohms. So write that resistance as it is in the network, that is 30 ohms. That's all. Now we have this particular circuit. Now just see how many nodes are present in this, and if you just see, there is a single node on upward side. On the top of it, यहाँ पर आपका एक ही node है. Why you have single node? The reason is that is nothing but the common node for all the branches which are connecting to that point. So this is your node number 1, and there should be a return node, and that return node is nothing but this point, this node, that is a return node, right? So how many nodes are present in this? The number of nodes present in this is 2. Now we have that expression. What is that expression? Number of node equations. Number of node equations is n minus 1 equal to, right? So now how many node equations are possible for this? As there are only 2 number of nodes present, so therefore n minus 1, that is equal to 2 minus 1 is equal to 1. So how many node equations or nodal equations possible for this particular node is 1. Is it clear with this concept? Or if you want to ask any question related to this particular slide, you are free to do so. We'll be going to have more and more number of numericals on this particular concept, as this particular subject is a numerical based, completely numerical based subject and conceptual numericals based subject. So therefore you need to understand the fundamentals, the concepts to be clear. So if you find any question, you are free to do so. You are free to ask me your question. Yes, any question? Any question? Okay, if you don't have any question, I just redraw this network so that we can form the matrix for this particular circuit. Okay, so now what we have? We have 2 parallel tracks, 2 parallel lines, and in between these 2 parallel lines, which are referred as node 1 and node 2, we have multiple resistance and current sources connected. So therefore those are, first, current source. The direction of that current source is upward. Second current source, whose direction is also upward. Then there are 3 resistances connected in parallel. So this is your 10 ampere, 10 ohms, 30 ohms, 15 ohms, and 5 ampere. Now, how many equations are going to be formed for this particular matrices? Circuit. There is a single equation that can be formed. A single equation that can be formed, right? Now, I think all of you are clear up to this particular point. Okay. Any question? No. Now, I just add one more circuit with this. यहाँ पर और एक मैं circuit लेना चाहूंगा. Okay. So now, consider this is your example number 2. See, we have not formed the equation for previous circuit. जो स्टेप मैंने वहां पर प्रीवियस सर्किट के लिए कंप्लीट किया था, लेट अस अप्लाई द सेम स्टेप टू दिस सर्किट आल्सो. कंसीडर अगेन there are two voltage sources which are present, 150 volt. On the other side there is 100 volt with 20 ohms on this side and 15 ohms on this side, with this resistance as say 25 ohms. This resistance is say 10 ohms and this resistance is say 4 ohms. And find out the current passing through this particular branch. That is I25 is question mark. Find out the current passing through 25 ohms branch. Okay. So what is your work is, as we have already crossed 115. 1:15 से ज्यादा हो चुका है. So therefore I don't want to take your much time, as it is a break time for you people. So therefore what you have to do in this particular circuit is you have to convert, you have to transform the present voltage sources, 150 volt, 15 ohms, and second voltage source of 100 volt, 20 ohms into current sources. That is only the task for you people. You have to just convert that voltage source into a current source. That's all. We'll see solution to that particular circuit, means for this and the previous one, in tomorrow's class. Okay. So fine, that's all. I'll just close my lecture here for today. I think all of you have noted the circuit. If not, can you let me know so that we can have 1 or 2 minutes? Yes, any question? Okay, now all of you please start putting the attendance in chat box. Same pattern, roll number 1 to 10, then 11 to 20, 21 to 30, and so on. If you have any question, please ask. Otherwise, please start putting down the attendance. (21 to 30) fast. (31 to 40). 41 to 50, 51 to 60, 61 to 65,